In this video lesson, we are going to talk about algebraic proofs. Now, there's really only 3 new reasons or properties that we're going to talk about in this video lesson. Otherwise, you know the properties of equality from algebra. So here's our new ones. Symmetric property. When things are symmetrical, we can kind of flip them over a line of symmetry. So this would be the B over here and then the A. So you can kind of notice that it basically just is flipped. The reflexive property, I want you to think of the word reflection like in the mirror. You see exactly the same thing in the mirror. Whatever is there, you see on the other side. So it's the exact same thing. A lot of times people get these two mixed up, so make sure that you are taking note of the difference between symmetric and reflexive. Transitive, I always think of kind of like a choo-choo train, transit. And we have basically these kind of train cars, and trains are always so long. Usually they make me late to school, it seems like. And so if they could just cut down and somehow get rid of those train cars that are the same or that they have in common, then we could just get to the important part of the train, the beginning, and the caboose. So putting the A equal to the C. Now, really, let's look at it as if A equals B, and B equals C, well then that means that A would have to equal C. And that's just kind of a logical thing we can get to, but transitive, I don't know, it's more fun with the train. But basically if they are equal to the same thing, then they are equal. So here's all those properties that you didn't know you knew already. The addition property of equality, you can abbreviate if you would like to with the first letters. That's fine. Or you can kind of do add prop of equality, or POE. There's lots of different ways to abbreviate. Now, subtraction, be super duper duper careful because substitution looks very similar. So however you want to, if you want to do SPE, that's fine. But substitution, do not do sub, because sub can look like subtraction. So, addition property, it's basically when you add the same thing to both sides. So if I were to add a 3 to both sides, that's the addition property of equality. Subtracting, if I were to subtract the same thing from both sides. If I were to multiply the same thing on both sides. If I were to divide the same thing on both sides. And distributing, you already know distributing from algebra. And then substitution is to replace, which most of you have replaced something. So if AB is 4, we're going to replace the AB here with a 4. So 4 plus CD equals 10. So those are your properties, and we're going to actually use those properties now. You have done these steps before in solving. Now we're going to add the proof, the reason for being able to do that. The first step is always going to be the given. I would say not always, but most of the time, 98% of the time, it's going to be given. Now, prove is not a reason. These are our reasons up here that we just talked about. So those are the things we're going to put on the lines. Prove does not describe anything. That's our goal, is to prove that x equals -4 by going through the steps. So how the proof works is we go from this step to this step and we see what did we do. And that's what we put on this line over here for step 2, is what happened from step 1 to step 2. So it looks like we got rid of the 8x and this 12x turned into a 4x. So how would we undo an 8x? On this side, we would subtract. So subtraction, property of equality, and or you can put SPE. Either is fine. And then we look to the next step. How do we go from step 2 to step 3? Well, it looks like they're getting rid of the plus 9. So we would, again, subtract the 9. And then we are going to go from step 3 to step 4. And that is getting rid of the 4 in front of the x. And how would we do that? 4 would be division, property of equality. So you can either do that or DPE. All right, so then our last step, it looks like they are just switching from step 4 to step 5. They are switching kind of the order. So we're kind of flipping it. So what was our flipping? If we go back up here, it's not the exact same thing, but flipping was the symmetric property. So that is our last step, is the symmetric property of equality, or just property. Again, not too concerned, as as long as I kind of know what reason you're putting. So again, step 1 is the given. If you want to go ahead and try to go from here to here, from here to here, each step filling in the reasons or the proof. A lot of times you might see the word reason. Excuse the baby. Let's go ahead and try that. So we have the distributive property for step 2 there, because they distributed the 3. Then we have from here to here, they are just adding those together. Now it's not the addition property because those are on the same side. So that would either be simplify, or you could put combine like terms. Either of those works. You don't have to put both. I'm just putting both since I want you to be able to see both options. And then the next step, from here to here, they're getting rid of the minus 12. How do we undo subtraction of 12? We add 12 to both sides. Notice they're not showing their work, because if we show this, that's an additional step. So then this step would be the addition, and then this next step would be the simplify. So it adds a lot, basically twice as many steps if you show your work. So those of you that are not keen on showing your work, well, this is one thing that does save you a little time without showing your work. So addition, property of equality. And the last step should have had division, property of equality, or DPE. Again, APE is fine too, as long as I know what you're getting at. All right, so that last one, again, if you'd like to try that one. If not, we can go ahead and do it together. So first step is the given. Next step is going to be distributing. So we are going to do the 4 times 5 and get 20x. We're going to do 4 times 9 to get 36, negative 2x, negative 14. So that is distributive property. Next, we are going to add the 2x to over here. So adding 2x to both sides was going to give me 22x. Minus 36 is equal to negative 14, and that was, again, addition, property of equality. And then adding 36 to both sides. So 22x is going to equal, when we add 36 over here, that's going to give us 22. And so that was the, again, addition, property of equality. And then our last step is to divide both sides by 22. So that's going to give me x equals 1, which is what we know is what we should have as our last one. Again, this is never prove. It's how did we go from this step to this step, and we did it with division. So division, property of equality. And that is your lesson on algebraic proofs.